We use ordered pairs to relate one quantity to another. Now, ordered pair also tends to look like an interval on a number line. So you need to be careful that when you're reading a problem that you understand which one we're looking for. Usually the context is incredibly clear. So suppose I want to write an ordered pair um, that expresses a relationship between the transportation and the amount spent. All right. Then the transportation is my first term, and the amount spent is $12,153. What if I want an ordered pair that relates the health care and the amount spent? That's health care, comma, 4,917. Now, the rectangular coordinate system is one you're fairly familiar with. You have an x-axis and a y-axis. You have quadrants 1, 2, 3, and 4. And a point AB means you go over in the x direction A units and up or down B units. So the first term is your x, and the second term is your y. So for the Cartesian or rectangular coordinate system, and we'll refer to both of them, if I have the point 3, 4, that means I'm going to go to the right 3 and up 4. If I have b is negative 5, 6, that means I'm going to go to the left 5 and then up 6. And similarly, if I wanted negative 2, negative 4, that means I'm going to go to the left 2 and then down 4. The distance formula is on the number line, it's the absolute value of x2 minus x1 or x2 minus x1. When we're in the Cartesian coordinate system, then the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So suppose I want to find the distance between P and Q when P is 3, negative 5, and Q is negative 2, 8. Then the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. You need to identify x1 is 3 and x2 is negative 2. Y1 is negative 5 and y2 is positive 8. Substituting in and keep your sign straight, you have negative 2 minus 3 squared plus 8 minus negative 5 squared. So this becomes 5 squared or 25, 13 squared or 169. So this is the square root of 194. Now, are the points 0, negative 2, 5, 1, and negative 4, 3 the vertices of a right triangle? What am I really asking here? I'm asking, do these distances satisfy the distance formula? So use the distance formula to find the length of each side. So the distance between 2 points is the square root of x2 minus x1 squared. There's a square there, it just doesn't look like it. Plus y2 minus y1 squared. So the distance between R and S is the square root of 34. The distance between R and T is the square root of 41. And the distance between S and T is the square root of 85. So use Pythagorean theorem. The longest side is the square root of 85. So that's got to be our hypotenuse, if it's a hypotenuse at all. So is the square root of 34 squared plus the square root of 41 squared equal to the square root of 85 squared? So does 34 plus 41 equal 85? No, actually it doesn't. So the 3 points do not form a right triangle. Now we say that 3 points are collinear if The sum of the distances between two pairs of points is equal to the distance between the remaining pairs. So are these points collinear? Well, the first thing you need to do is find the distance between P and Q, and that is 2 square root of 2. The distance between Q and R is 8 square root of 2. And the distance between P and R is 10 square root of 2. So the first distance is 2 square root of 2. The second distance is 8 square root of 2. And the longest distance is 10 square root of 2. So does the distance between P and Q plus the distance between Q and R equal the distance between P and R? Substituting it in, we get, yes, they are collinear. Now, suppose I want the midpoint of a line that's not horizontal and not vertical. The x value of the midpoint is the average of the two x values. So it's x1 plus x2 divided by 2. And the value of the midpoint y value is the average of the y values, or y1 plus y2 divided by 2. So suppose I want to find the coordinates of the midpoint of the segment with endpoints -7, -5, and -2, 13. The midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Substituting in your numbers, you get -9/2, 4. Find the coordinates of the other endpoint of Q of a segment where one endpoint is P and the midpoint is 4, -4. Okay, so let xy be the coordinate of Q. Using the midpoint formula, I have x plus 8 divided by 2, comma, -20 plus y divided by 2 has to equal my midpoint, or 4, -4. So I can treat this as two separate problems. X plus 8 divided by 2 is 4, tells me that x has to equal 0. And -20 plus y over 2 equals -4, tells me y is 12. So the coordinates of Q are 0, 12. Feel free to go and recheck your answer as well. Now, the total revenue of a full-service restaurant in the United States increased from 124 billion in 2009 to 137.4 billion dollars in 2013. Use the midpoint formula to estimate the total revenue for 2011 and compare that to the actual figure of 130.6 billion. So the endpoints of the segment are 2009, 124, and 2013, 137.4. So using the midpoint formula, we get 2011, 130.7. So the estimated total sales in 2011 were 130.7 billion, but the actual amount was 130.6 billion. So it is off by 0.0 or $0.1 billion. So this was actually a pretty close estimate. Now, sometimes we're going to have equations with two variables. Ordered pairs are used to express the solutions in two variables when I give you an equation in two variables. Find three ordered pairs that are solutions. Now, these aren't going to be unique, so you may pick different numbers than I do. So set up a table and pick three numbers. I like -1, 0, and 3. When x is -1, I substitute -1 in for x, and I get y is 7. When I pick x as 0 and I put 0 in for x, I get y is 5. When I pick x as 3 and I put 3 in for x, I get -1. So my ordered pairs are -1, 7, 0, 5, and 3, -1. If you do this, you can pick three totally different numbers and get three different solutions. Suppose I want to find three ordered pairs that are solutions to x is equal to the cubed root of y plus 1. In this case, I'm going to pick values for y and substitute them in. So when I pick -9, I get x is the cubed root of -8 or -2. Now you're going to notice I picked it very smartly so I can take a nice cubed root. When y is -2, I get that x is equal to -1. And when y is 7, I get that x is equal to 2. So my ordered pairs are always x, y, no matter how I gave you the equation. So my ordered pairs are 2, -9, -1, -2, and 2, 7. Now suppose I want three ordered pairs that are solutions to y is equal to -x squared plus 1. So I'm going to pick the numbers -2, -1, and 2, and substitute those into y is -x squared plus 1. When I do that, I get y is -3, 0, and -3. So my ordered pairs are -2, -3, -1, 0, and 2, -3. Now suppose I want to graph. You can do graphing by plotting points. In order to do that, you need to find the intercepts. You find the y-intercept, that's when x is 0, and the x-intercept is when y is 0. And then you find as many additional ordered pairs as you need. Plot the points and then connect them with a smooth curve. So suppose I want to graph y is -2x plus 5. So you need to find the x-intercept and the y-intercept. To start with, let's look at when y is equal to 0. So my x-intercept will be when 0 is equal to -2x plus 5, or x is 5/2. The y-intercept is going to be when x is 0. So the y-intercept is at 0, 5. So now that I have my two intercepts, I can graph them. Now I can use other order pairs. All right. In reality, for a line, once you have the intercepts, you've got enough information. You just simply plot them and then connect with a smooth straight line. Please use a ruler when you're graphing lines. So to graph x is the cubed root of y plus 1, we want to find the x and y intercepts. So in this case, I'm going to set x equal to 0. So I find the y-intercept is y is equal to -1. To find the x-intercept, I set y equal to 0. And I get the intercepts are 1, 0, and 0, -1. Now I want to find some ordered pairs and plot the points given and connect in a smooth curve. Suppose I want to graph y is equal to -x squared plus 1. Now I need to find the x-intercepts and the y-intercepts. So to find the x-intercept, I set y equal to 0, and I get x is plus or minus 1. To find the y-intercept, I set x equal to 0, or I get y is equal to 1. So I have the intercepts, -1, 0, and 1, 0, and 0, 1. I'm going to find other ordered pairs that I found in another problem, plot, and connect in a smooth curve.